Imagine this. A tiny spacecraft, no heavier than a paperclip, racing through the galaxy to explore one of the universe's most mysterious phenomena, a black hole. Sounds like science fiction, right? But here's the twist. It might not be as far-fetched as you think. Scientists are already sketching out plans for such a mission, and while it's still decades away from reality, the concept is grounded in real physics and emerging technologies. So, how close are we to pulling off this cosmic adventure? And what challenges lie ahead? Let's dive in. The idea revolves around sending an interstellar nanocraft, essentially a miniaturized probe equipped with advanced sensors and a light-powered sail to investigate a black hole. If we can locate one within 20 to 25 light-years of Earth, the journey could take less than a century. That may sound like a long time, but in the grand scheme of space exploration, it's practically a blink of an eye. The key lies in leveraging cutting-edge propulsion methods like laser-driven light sails, which could propel the craft to speeds approaching a third of the speed of light. Cosimo Bambi, an astrophysicist at Fudan University in Shanghai, has proposed a detailed blueprint for such a mission. According to his calculations, the technology required for this endeavor could become available within the next 20 to 30 years. What makes this plan particularly exciting is its potential to test Albert Einstein's theory of general relativity in ways we've never been able to before. By getting up close and personal with a black hole, scientists could examine how extreme gravitational forces affect the fundamental constants of physics, shedding light on some of the universe's deepest mysteries. But here's where it gets controversial. Locating a suitable black hole isn't as straightforward as pointing a telescope toward the nearest star. Black holes don't emit light, so they're invisible to traditional observation methods. Instead, astronomers must infer their presence by studying how they warp the light of nearby stars or influence their surroundings. While the closest known black hole is about 1,500 light-years away, far too distant for a nanocraft to reach, statistical estimates suggest there could be a black hole lurking much closer, perhaps within 20 to 25 light-years of our solar system. Finding it, however, would require significant advancements in detection techniques. Once identified, the next hurdle is the journey itself. To cover the vast distances involved, the nanocraft would rely on a massive, ultra-high-powered laser to accelerate it to incredible speeds. This approach, though theoretically sound, comes with a hefty price tag. Bambi estimates that building such a laser could cost upwards of €1 trillion. And even then, the mission wouldn't come without risks. For instance, slowing down the craft once it reaches its destination remains an unsolved problem. Bambi's solution? Don't bother decelerating. Instead, the mothership would release smaller probes to gather data during high-speed flybys, transmitting their findings back to Earth via the main craft. To truly test Einstein's theories, Bambi proposes sending not just one, but 2 miniature spacecraft. One would remain at a safe distance, acting as a communication relay, while the other ventures closer to the black hole's edge, collecting invaluable data along the way. This dual probe strategy highlights the ingenuity required for such a mission, but also raises questions about its feasibility. Could we really engineer something small enough, yet durable enough, to withstand the rigors of interstellar travel? Geraint Lewis, an astrophysicist at the University of Sydney, acknowledges the ambition behind Bambi's proposal, but points out a potential flaw: the timeline. A century-long mission means the technology used today could be laughably outdated by the time the craft arrives at its destination. Given 100 years of technological progress, Lewis muses, who knows what kind of engines or propulsion systems we'll have invented by then? It's a thought-provoking question that underscores the speculative nature of the project. And this is the part most people miss. even if we succeed in launching such a mission, humans won't be aboard. The intense acceleration forces, upwards of 10,000 G, would be fatal to any living organism. Unless, of course, we stumble upon a wormhole, a la the movie Interstellar, which could serve as a shortcut through space-time. Bambi admits this possibility is purely hypothetical, at least for now. In my proposal, unfortunately, there is no wormhole, he says with a wry smile. Sam Barron, a philosopher of science at the University of Melbourne, describes Bambi's paper as one of the most speculative he's ever encountered. Yet, he notes, many groundbreaking ideas once seemed equally far-fetched. Take the Large Hadron Collider, for example, a marvel of modern engineering that was once dismissed as pure fantasy. The use of something very small like a nanocraft is probably the way forward, Barron reflects. The real challenge is whether we can actually build something capable of doing everything outlined in this paper. So, what do you think? Is exploring a black hole with a nanocraft a realistic goal, or is it destined to remain a pipe dream? Could future breakthroughs render this proposal obsolete? Or does it represent the first step toward unlocking the secrets of the cosmos? Share your thoughts in the comments below.